Good morning, student. Let's start today's class. Okay. Today we'll discuss about or we'll continue our uh, digital data to digital signal conversion techniques. In previous classes, we have already studied about NRZ. NRZ. What is NRZ? This is non-return to zero, and there are two types of NRZ. One is NRZ-L and one is NRZ-I. What is NRZ? Non-return to zero, non-return to zero level, non-return to zero inverted. Okay, this much we have already studied. Okay, now from we can now from today's class we will study about uh, non return to zero. Okay, return to zero. Previously we have studied non-return to zero, okay, techniques, but there is some problem in return to non-return to zero, because what is the problem? The main problem with the NRZ encoding occurs when sender and receiver clocks are not synchronized. Clock pulses are there in the transmission. If these clock pulses of sender and receiver are not synchronized, that is the problem in NRZ. The receiver does not know when one bit has ended and the next bit is started. That means if the clock pulses of receiver and sender are not synchronized, then what happened? The receiver cannot uh, identify the starting of the bit and the ending of the bit. Okay, when the bit is started and when the next bit is when that bit is ended. That information is not there in receiver end. That is the problem, and to overcome this problem we use return to zero. In return to zero there are three in return to zero we use three values. In non return to zero we use two values. One is positive value, one is zero voltage. Okay, one is positive voltage, one is zero voltage. Here you see in NRZ one is positive or one is negative, or one is positive or one is zero. Okay, we've used only two values, but in a return to zero we use positive, negative, and also use zero. That means in NRZ in NRZ we can use sorry in NRZ we use two values. Okay, it is NRZ. Okay, this is T. We use this positive, zero, positive, zero, positive. Okay, this is NRZ, and we use this is unipolar. Okay, and in polar NRZ there are two types, NRZ-L, NRZ-I. Here we use positive and negative, and positive and negative. Okay, so in NRZ we use two values, but in non but but in non in return to zero method we use positive, but positive, negative, and zero. Okay, and in NRZ the signal changes not between bits but during the bits. But in NRZ what happened in NRZ, one bit 0, one bit 1. Okay, and this signal, this 1 is changes to 0 level. Okay, in between two bits. This is happened in NRZ. In NRZ the bit or the level of voltage is changing in between 2 bits. Here you see this changing, okay. But in return to 0, what happened, this here you see in return to 0, this is 1 bit, this is 1 bit, okay. This signal is changing half of the bit or during the first bit, and again it changes in the during of the bit, okay. That means the bit is divided into two halves, okay. One half is follows one half here is the here you see the that means uh, the bit in return to 0, the one bit is divided into two halves, okay. One half represent one level of voltage and other half represent other level of voltage. That means the voltage level transient or the voltage level transmit, okay, or the changes in duration of the bit, okay, not between the two bit, okay. Here the signal changes duration during the first bit or during the bit, okay. The idea of return to 0 or transaction at the middle of the bit and the idea of NRZL are combined into the Manchester scheme, and these using the return to 0 concept, there are two types of scheme, and yes, also we now we see there is a technique this which is called biphase, okay. This is biphase technique, okay. And in biphase technique we use return to 0 concept, okay. That means we use uh, the we divide the one bit into two halves, and one half represent one level and another half represent another level, okay. That that concept, that return to 0 concept is used in biphase technique, okay. And biphase technique are two types, one is Manchester and one is differential Manchester, okay. In in Manchester, what happened in Manchester stream, what happened, the idea of NRZL and the idea of are return to 0 are combined into Manchester scheme, okay. And because that is the return to 0 and NRZL are combined to give the Manchester scheme, okay. In Manchester encoding, the duration of the bit is divided into two halves, okay. The voltage remaining at one level during the first half and moves to another level in second half. The transaction at the middle of the bit provided synchronization, okay. And also in Manchester scheme, you see this is the Manchester scheme, okay. And the Manchester scheme here, for 0 binary bit 0, the energy level going high to low, okay. And for binary 1, the energy the signal going from low level to high level. Remember this is the main concept, okay. And now see our waveform. This is given the data, okay, digital data. We can convert this digital data into the digital signal by using Manchester scheme. How we convert, let's see, okay. Due to this is 0, okay. We know 0 in 0 signal from high to low, so this is high to low, okay. And for 1 we know from low to high, and again here due to 1 low to high, then 0 that is high to low, and 0 that is high to low, and 1 that is low to high, and 1 that is low to high, and we connect these two, okay, and we get our waveform, okay. So you should remember these two concepts for Manchester. Okay, then by using this concept you can draw the waveform, okay, for given digital signal. Okay, next, in differential Manchester and in differential Manchester, on the other hand, combines the idea of return to zero and non-return to zero inverted. The Manchester is the combination of NRZ, L and RZ, but the differential Manchester is combination of RZ and NRZ I. Okay, there is always a transition at the middle of the beat, but the beat value are determined at the beginning of the beat. If that means in Manchester, what happened? The transition is uh, in between the beat, okay, or during the beat, okay, or middle of the beat, uh, and the value which determine, or the value, that means we uh, determine or we consider the value in the middle, okay, for zero in middle we will, or but in what differential Manchester, the transition, okay, transition at the middle of the beat, same as Manchester, but the beat value are determined at the beginning. That means at the beginning the beat value we determine, okay, but or the next beat value is what is we consider or we take care in the beginning of that beat, okay. And if the next bit is 0, there is a transition. If the next bit is 1, there is no transition. Remember, sorry, remember this. For differential, remember this much. Okay, 0. If there is 0, transition. If there is 1, no transition. Okay, remember this much. Okay, and now see, or now see how can we construct our web digital signal from digital data. Okay, here the digital data given. Okay, and remember 0 means transition, 1 means no transition, and we consider it at the beginning. Okay, from beginning here, due to 0, okay, then due to 0 the transition happened. Transition means this, and it is considered as a non-zero inverted. In non-zero inverted, 0 means low, okay, 1 means high, okay, inverted, non-zero inverted. So for 0 we consider this low to high. Then the next bit 1 is the next bit, then the next bit is 1, okay. So in 1 we know no transition. No transition means, or no transition means from beginning there is no transition, okay. So it continue the level, and in middle it transit. That means in beginning there is no transition, but in middle there is transition as like as uh, inverted, uh, uh, NRZ inverted, okay. And here next bit is coming bit is 0, okay. So there is a transition. That means transition in beginning, this level is going upward, okay, straight going upward, okay, and then usually transit, okay. That means here you can here you can what here you can see the two transition are there. In the starting there is transition due according to differential transistor, and in middle there is according to NRZ inverter. Okay, and next bit is 0, and this signal is transient again. Okay, transient mean uh, from from the level in which it placed, it transit to another level. Okay, transit, and due to next level is 1, it does not transit. Okay, it continue their level. Okay, and for next bit is 1, it did not transit, it continue their transition. Okay, okay, thank you.